Hello, class. I wanted to start today's video off with the following helpful algebra note. Namely, we've been using an awful lot that if you sum the powers 1 plus x squared plus dot 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 and you never stop, then that's 1 over 1 minus x. But if you do stop, then you get the following formula, which is not quite as nice, but is similarly nice. In fact, if you want, you could imagine that x is between 0 and 1, and if you took the limit of this as n went to infinity, then you would get our formula from before, that this is 1 over 1 minus x in the limit. Okay. But this will be helpful for us in today's example. There's a few different ways you could go about proving this. If you are skeptical, one is that this is actually the finite geometric series formula. So if you've thought about a finite geometric series within the past, I don't know, however long, you might recognize it. Or if you want, you could multiply both sides by 1 minus x. And then if you actually multiply this by 1 and then multiply it by x and subtract that, you'll see that almost every term cancels. In fact, the only terms that don't cancel are the ones on each end. And so the one on the left will be 1, and then the one on the right will be minus x to the n plus 1. So however you want to go about it, you can use this freely forever. But before we go on to talking about partitions, which is what I promised I would do in this video, and we're not going to, I wanted to give you a chance to try one of these exercises yourself. Okay. And so I'm going to give you a very, very natural looking exercise. So I'm going to say that we're going to buy n pieces of fruit. And so the fruits I can buy are apples, pears, oranges, and bananas. But for inexplicable reasons, I'm only allowed to purchase an even number of apples. I'm only allowed to purchase a number of pears that's a multiple of 5. I can only have at most 4 oranges. And I'm only allowed to have 0 or 1 bananas. Okay. So I'll go ahead and call the number of ways I can do this, let's call it S of n. And so what I really recommend you do before I go ahead and figure this out is I want you to try and write down a function that is a nice way to represent the function for this power series, sum as n goes from 0 to infinity of S of n times x to the n. And I'll do it in a minute, but again, try and write this down in some nice way first, and then check back with me. And also, if you want to challenge, before I go ahead and ruin all of this for you, you can also try and figure out an explicit formula for S of n, because by the time we're done this, we're actually going to have an explicit formula for S of n, believe it or not. Okay, so pause the video here, look at it, and then come back and we'll do it together. Three, two, one. Okay. We're back, so hopefully you've now gone about doing this. So this thing is going to be a product of some term for the apples, some term for the pears, some term for the oranges, and some term for the bananas. Okay, so let's look at the apples first. So I can buy an even number of apples. So that is to say I am allowed to purchase 0, 2, 4, 6, 8, and so on apples. So that would be this. And so on like that. Times, and I'm allowed to buy only a multiple of 5 number of pears, so that'll be 1 plus x to the 5th plus x to the 10th plus x to the 15th plus dot dot dot. At most 4 oranges. So 0, 1, 2, 3, 4. And 0 or 1 bananas. So that would look like 1 plus x. So the 1 is no bananas, the x is 1 banana. And so when you multiply this out, all out, every way you could end up with a term of x to the n corresponds to a way of buying n pieces of fruit that follow these bizarre rules. Now, we can simplify this a good bit, okay, because the first term here is 1 over 1 minus x squared. The second one is 1 over 1 minus x to the 5th. Okay. And actually, I can write these two using the helpful algebra note from the beginning of the day. So using the helpful algebra note from the beginning of the day, this one is 1 minus x to the 5th over 1 minus x times, and then this one is 1 minus x squared over 1 minus x. And you'll notice, actually, there's some cancellation, because that cancels with that cancels with that. And so this is 1 over 1 minus x all squared. Sorry. And actually, we've seen a couple times now in a couple different ways that we actually know the expansion for this. Namely, the power series expansion of this function is n plus 1 times x to the n, as n goes from 0 up to infinity. And so, if you think about it, the coefficient of x to the n, that's the number of ways to answer this counting question. And so what this tells us is that the number of ways to purchase fruit, based on this, the number of ways to purchase n pieces of fruit, it's actually exactly n plus 1. Okay, and so for example, just so that we're clear, if I want to purchase 10 pieces of fruit, you can check there are 11 ways I can do that follow these rules, which is kind of fascinating. Okay. I'll leave you with a challenge. I would love it if one of you could show me a proof that you get this that does not run through any calculus. So I would love a proof that really the number of, or the answer to this question is always n plus 1, that just sort of follows what we would have done before the class. And if you want, you're free to discuss it on the forums and bounce ideas off each other and see if you can come up with something. All right. Next time, we really will talk about partitions. But until next time, be well.